there are three main categories, main topics in operating system. First one is the processor. Second part actually we skip because of the second project for your bootable file system. So we cover the third part first, that is the I/O management. So this chapter is the last chapter of the I/O management. So basically, what is the two main operation in computer, in any computer? Computer is doing computation, right? So computation is the first, I think the most important part is mostly done by the CPU, the processor. The processor compute the operation based on the instruction. Then another main operation is what? So CPU deal with what? The information, what data. So data is a structured information. So CPU can understand and process and compute such an instruction, structured data, structured information. So where such a data are stored is a storage. So we have discussed about such a storage. Sometimes it's secondary storage. The memory can be considered as the storage also. It's the first storage that the CPU can access the data. And so these data actually based on what? The input and output and transfer the such a data. So input and output I/O is the another important the operation in any computer or any microcontroller, any the electronic devices. So in this chapter we are going to talk about such a input and output I/O management. By the way, where can you find such an input and output mostly? It's a hard disk drive, right? So you can store the such data in the hard disk drive. Sometimes the hard disk drive can be based on the different the hardware. So we have seen in the chapter 10, 11, the variety of the such a storage. So sometimes such a I/O is not only from the disk storage. Okay, you can find such an input and output operation from where? Even projector is one of the output of the output device of the computer is connected to the computer. Okay, so input and output can be human interface. Nowadays, the human interface is the relative. It's not new, but relatively so has been focused on the recently a lot in the computer science subject. With the developing of the what? The portable devices such as a smartphone or the nowadays the iWatch or the wearable devices, okay, at the time. So what is the example of the such a input and output the interfaces for human being? You can, the output device include the monitor. The long time ago we used the CRT monitor, okay. Then it's nowadays screen, even it's a touch screen. So screen is not only for the output device but also input device also nowadays. So every day you are swapping and touch your smartphone, the screen or the iPad or the note, what else? So even your laptop has a touch screen. So that is another input and output. What else? What else the input and output devices that you can use? So for the input device, let's turn into the input device. Input device you can use also touch screen as we just a keyboard and mouse. By the way, it's a different story. Do you think these are the human friendly or user friendly? Actually, why don't you think about the in my opinion, any computer science subject are related to the human being. Okay, so we try to develop the electronic device that can help or sometimes replace the human activity. Like the CPU is similar as a brain that can process the information. Okay, using the input and output device. Sometimes my voice is the output device. Also my hand, if I can use something, the motion or gesture, that can be also the output. Also, as an input, we can use the eyes or the hearing system, and also what else? Sometimes sense, and for the disk drive, the disk storage, it's kind of something we'd like to keep the information that we cannot memorize forever in the notebook, or sometimes writing something, and sometimes we keep the memory information in our brain. That is kind of the memory structure. So pretty much the computer science subject is quite similar as what human being is doing. In this perspective, what about the computer, the input and output devices? So everybody use what is this? The mouse. So but have you ever used such a mouse type, the interface? No, actually it's not very human friendly. And what about the swipe? So we do not use a lot for the fingering for the communication. So that's the reason there are a lot of opportunity to develop the new device, new interface in computer. Okay? So not only just it will be eventually touchless. Okay? Nowadays, without touching, it's very hard. There are some motion detect, but it's very basic level of the motion detect to control your device. Most of them are touch-based. So mouse is also touch-based. So you need to do something with your finger, right? And what about your smartphone? So you need to touch, swipe, and or click with the mouse. So eventually, it's called HCI, human-computer interaction. So human-computer interaction will be not only just improving the power of the computer or speed of the network, but it's a time to focus on how much we can develop the convenient the device for human being. So at that time, if you want to do something, so anyway, so such a device should be understood by the computer, especially the CPU. And who controls such a thing? Operating system. Operating system is a software between hardware and the user. So through the operating system, we need to control and communicate with such a device. So in this chapter, we will see such an input and output system in our computer architecture. Okay. So another reason why the I/O management is important in computer system is because input and output is much slower than the CPU process computing. So I said that there are two main operations. One is computation, another one is I/O operation. So which one is first? Definitely the computing operation is much faster. It can process the tons of millions of instructions per second even. But I/O is when you see when you access the data in the hard disk drive, that is even the thick time, a lot of latency, and to get the data, it takes much longer time. So to address that problem, we have another computing architecture, another layer of the computing architecture, that is the memory as a cache purpose. So we can put the data in the memory, then the CPU can be still that's slow. So we have another layer. So add to cache also, eventually we store the data in the register. That is the register that the CPU can access the data. So how to speed of such I/O input and output from the device is very, very critical for the overall performance of the computer system. In other words, the I/O part is a kind of a bottleneck of the computer system. Okay. So, also another difficulty of the such I/O management is nowadays a lot of the I/O devices are standardized. So we will see the difficulty of the such a thing, but each and every device has their different. They have the different the data structure for the communication. If we have the standardized, it's much easier to connect it. However, operating system, your computer system does not know all of the interface, how they are communicate. It's also data structure. Such a data structure are vary depending on the devices. So how can we handle such a thing? We will see. It's go through the disk controller adapter. So we don't know how many devices are existing in the world, right? So many devices. Sometimes you cannot, even though I have the new device, I cannot use if your operating system computer does not know the data structure of the communication between your computer and the new devices. So there's another difficulty of the I/O management. Definitely, we need to consider performance, okay, especially to access the data as a storage. So basically, such an I/O system include port. What is a port? It's a bridge port. What is a port, by the way? It's a port to go out to the world, right? And so people are coming through the port, airport, and the seaport. Okay, so that is a port. It's the same thing in the computer. So port is a common area. Okay, common area between that connect the device and your computer. So there's a port. So when somebody coming from the ferry using the bridge port, then they will take the road, okay, drive the road, okay, to go to the other. Like I live in Trumbull, so I'd like to go to Trumbull. Definitely, I will take the I-95, then the route to 25, then finally go to. So in computer, it's the same. So why do we need the input and output device, I/O device, for transferring the data, right? So that's the only purpose. Any device, so for example, input device touch screen, your action will be converted into the digital format, then transfer to the CPU. Then CPU understand what the user want, then operate such an action through some system code and the application, something like that. So how can we transfer such a data? How can the visitor can visit the other place using the highway? That is the bus in the computer architecture. So there are different types of bus, but some of the bus are very fast, sometimes slow. So we will see such a buses. And if you coming to the port, airport, who is the first guy to meet? So there's an immigration office, then they control. Similarly, in the computer, so there's a port, but port is a common area, common device to connect the new device, any device, and the computer. And there's a bus, but who controls such a thing? CPU. CPU does not know everything. CPU just compute the instruction. Then if instruction has a certain data, like the read data A, then ask to the bus. No, bus is just command structure. The port is just command structure, and bus is the way. So there should be something area that can control, that can receive the order of the operation from the CPU computer, then ask to do something for the device, that is controller. So as you have learned in your computer architecture class, so the device should be connected to the controller. Controller is kind of a computer, small computer. It's an embedded computer that has their own programming. Okay, sometimes it has a register, sometimes it's a process. Okay, then they receive the order from the CPU, then they control the device. That is a controller. So any device should connect to the controller. This is one common mistake. So somebody said the mirroring is very good for backup purpose as well as the parallel processing. So I try to mirror a file. So I have a C drive in the file system. So I divide the C drive into C drive and D drive. Then mirror the file and try to access the file parallelly. Can you get the speed up? And is it safe? No. Until that the the partition is separated by the disk controller, you can even though you have the 2-3 different physical hard disk drive. If all of these are connected to the same controller, that controller will be bottleneck. Okay, you cannot get the linearly increased scalability. So this is common mistake when you design your system with many hard disk drive. The key part for the bottleneck is how many the disk controller you have. So one disk controller, for example, SCSI disk controller can manage up to the 15 devices, which means you can connect the 15 hard disk drive to the one SCSI controller. So at that time, if the disk controller is bottleneck, it can process SCSI usually process 15 megabyte per second, something like that. Even though you distributed your file, you cannot get the linearly increase the scalability. Okay, in terms of performance, that is the IO management. So such a program that can control a device in the controller is called the device driver. So that is a reason long time ago. So when I purchased a new hard disk drive, so it was I think around the 20 megabyte, less than 20 megabyte hard disk drive, something like that. Even Windows, my new Windows 95, the operating system cannot understand, cannot read the data, recognize such a hard disk drive because the operating system does not know the data structure, communication method of such a new device. So I need to insert who provide such a program at the time. The device manufacturer developed the program that should be installed in the disk controller. Then the operating system can read the data and ask the specific operation through such a the disk controller. That program is called the device driver program. Nowadays, many of the such a devices are standardized. So you can have, for example, USB. Okay. So USB U stands for universal, and many of them are standardized. Also, now, so if you developed a new device, actually there's a program in the well-known operating system manufacturer, such as Microsoft or the Apple. So you can get actually they have the long-term plan of the operating system. So at least within 10 years, it's already the timeline. So there's a code name of the new operating system. So they provide such a standard for the devices. So if you develop the device, you can follow their standard, and if the Microsoft allows, it will be part of their operating system. So you don't have to provide your driver program to the customer. Instead, when they are connected, then it's automatically installed. Okay. So first, hardware. What kind of the hardware we have? There are three main parts that I already discussed. Oh, by the way, the storage is not the only I/O devices, as I said. So it has a transmission, it's like the bus, okay? So like the Scotch bus or Scotch that is control bus for the PCI bus or the PCIe bus, and such a device also I/O devices. And interface means like the input and output, the devices like the screen, touch screen, and the mouse, and so on. So these are the I/O devices that should be considered under I/O management. And these are the concept of the I/O input and output hardware. We have a port already. We have already discussed this connection point for the device that are common. The connection between the device and the computer. And bus is the like the highway to transfer the data from between the device and especially for the controller and the computer component such as memory, processor, and others. It's called the daisy chain. So daisy chain means the a bus A. For example, we have the different types of bus. Bus A is connected to the B, and B is connected to C. It's serialized connected. That is called the daisy chain. It's kind of the pipeline approach. So PCI is the most popular, the bus in the personal computer, PC and the server, and PCIe is more faster, 16 gigabyte per second. Okay. And controller is the host adapter. You know the adapter. Adapter is the when you use the power of the wall outlet, so you need to connect the adapter that can reduce the voltage of your that feed to your device, something like that. The device should connect to the controller to communicate with the computer system. Okay. It's an electronic device. It's a small electronic device, so that should have the program. It's called the device program. Also, it has their own memory. Okay. It's a small computer. Even this controller is a kind of embedded computer. So it has even the register, at least a full register, the data in and out, and status register, and just on a Google sheet. So if we want to develop a new device, I have a new device that can be used for the input and output device of the computer. At that time, you need to not only design for this one, you need to design how to transfer the data. At that time, you need to decide which controller you are going to use, and where can you find such a data structure of the controller. There are standards. So if you want to use a USB, there is a USB standard. So if you already took the microcontroller class, so you learned how to control the mouse from the instruction. Okay. At the time, the mouse and the hard disk drive is at the time you should use the instruction that can order the disk controller. So there is a standard for the disk controller. If you want to use the VGA, the 19 pin, each pin, so you can specify that this data is go to the first pin or second pin. So that is a reason, even though sometimes some of the pin is broken, you can still use it because you don't have to use all of the pin to transfer such a VGA data. So instead it can be used for transfer the hard disk drive if you want, but slow, right? So there are standards, so you can use it. Then you can make a program for your the driver. This is a typical personal computer bus structure. You can see the main highway, like the I-95. Okay, so this is a bus. Okay, then all this controller is connected to the bus, and under the controller we have the, for example, ID disk control, the disk, okay, the hard disk drive, the device, and through the expansion bus is the expansion of the PCI bus as the parallel serial, which is the command, the port, and the keyboard, and so on. And also SCSI is the manage the hard disk drive. Mostly the SCSI manage the hard disk drive up to the 15, and also processor is go through the bridge memory controller. Any device in the computer goes through via the controller, then connect to the bus. Then they can communicate each other. So there is I/O instruction. If you already learned the assembly language, then such a I/O instruction can control the devices, which means there exists the register in the disk controller, data in register, data out register, status register, and yeah, last one is a control register. So they are typically 1 to 4 byte. 4 byte is the word format, and also they manage the FIFO buffer, the first in and first out, in case. So one controller may receive the multiple requests that can be processed by the mostly the FIFO, the first in and first out buffer. And also definitely when you have the many disk controller device, so operating system manage the queue for each device, then schedule. Okay, in the operating system level, manage. So suppose that you have the multi-core, or the definitely not even the single core, the processor. So there might be the multiple program. So each program requires the different I/O for the same controller. So operating system level control the which will be the next one using the schedule. Then each controller has the FIFO buffer to the process one by one, first if possible, the multiple instructions same time. There are two types of to control the I/O. Basically, one is directly order the directly use the I/O instruction, then read the data for to the disk controller. Disk controller understands the instruction, then the action for the devices. Another way is a memory map I/O. We can actually in the memory, so we will map such each device. It's an incomplete list. So for the specific address, okay, you can map this one. Or if you took the microcontroller answer, so you use such a memory map, the address to read, to control the specific item, like the mouse. And DMA controller, we will see the later. So for example, it has a timer, okay, to get the real data. Also, for example, if you want to access the parallel port, so if you have any device that connects the parallel port, you can actually port such an address information. Then you can use that the device instead of sending instruction directly to the disk controller. So there are two types. In other words, each device is mapped to the specific address of the memory. Then, instead of send directly the I/O operation instruction to the controller, you can actually get read the data from such a memory address. Then, how the CPU operating system know which device is available, which device not? The first approach is the polling. What is the polling approach? I think that we have discussed it before. polling is keep checking. Okay, so if you want to see me, so you probably come to my office. Then if door is open, then you can find me. Otherwise, you need to go back. Then after 1 minute, and check it again. And after 1 minute, check it until door is open. Right? It's a polling. Okay. But in the CPU and computer, it's not like every minute. It's every millisecond. Right? Then the polling usually busy wait. It's a waste of the CPU resource. So I think that we have seen in the synchronization critical the section problem. So to check whether the critical section is available, one of the approaches keep checking using the while loop, right? Until it is changing. So this is a polling. It's the same thing. So you can read the BC bit in that instruction. The status, the register. So we have seen the register. One of them is the status register. Status register. So set 0, that means available, nobody used. 1 means it's been used currently. So until it's at 0, so keep checking. So called the is waiting. Okay? That's the way so it can degrade performance. Okay, then if the write operation copy the data into data out, okay, data out register, and then if you host your operating system or the CPU would like to write the data and change the read or write bit into the 1. Okay. Then set the command ready bit, then finally execute the operation. This is a polling approach. Another one is the interrupt approach, because this the host, the operating system or the CPU keep checking. That is a waste of the resource, and not good for the performance. So we can interrupt, as we have seen the beginning of this class. So the current operating system is based on the interrupt. Then the CPU can interrupt the I/O devices and send the data, send the instruction to the disk controller. At that time, you don't have, you can send the instruction by instruction to the controller, or sometimes you can send a set of instruction for better performance. That is called the interrupt method. So you can dispatch the interrupt, the set of interrupt to the disk controller. Okay, so at the time you can reduce the context rate and get the better performance. So this is the diagram showing how the interrupt-based I/O is working. So this is the CPU, your processor part, and this is your I/O controller. So from the CPU, you wanna initiate the I/O at the time and interrupt, send the interrupt signal to the I/O controller. Okay. Then the I/O controller realize there is a request from the CPU, and the set the register be ready for that, inform to the CPU. Then when the CPU receiving the finalizing such interrupt and transfer the instruction to the controller. Okay, to the interrupt handler. Okay. Then interrupt handler is operating system made by the operating system process such the instruction. Okay. Then it will get done and return to the CPU. That is the one cycle of the interrupt driven into the output. So this is the example of the Intel Pentium processor, the event vector table. So you can use such the interrupt handler in operating system manage such a thing for the interconnection processor. Okay, so by the way, even we can use such a interfactor or the inter-based approach for the input and output rather than the direct instruction-based input and output. So still slow. Why? Because anyway, whenever you read and write the data, you need to go through what? CPU. CPU needs to send the interrupt, not interrupt. CPU should send instruction, I/O instruction to the controller. That is a main. Sometimes you can directly send such an instruction to the controller, or sometimes it can be based on the interrupt. So anyway, it's just slow because you need to any input and output go through the CPU, then store at the memory, then finally the CPU read the data into the register, then process it. So it's okay when you read just a small size of the data. What if you have the 1 GB size of data? So waste of the resource. Instead, let's take a look at this diagram. It's called the direct memory access. So which means, so instead to go through the CPU and cache, it can directly read the data from the disk controller. Definitely, this controller is in charge of to seek and read the data using the sector number, cylinder number, track number. Then we already discussed in the previous the chapter. Then send the data using the DMA. The controller, there exists the DMA controller directly stored at the memory. Okay. Then once it is done, in this case it's a size C by is a transfer, then the CPU can read the data. At that time, the CPU, the data should be doesn't have to go through the CPU. So that can reduce a lot of overhead. So it's much faster. So that is called the DMA, direct memory access. Okay. So that can avoid the program I/O input and output. It's not if we have such a program I/O is 1 byte at a time, so it will be slow. So, but we need the we need the controller to perform such a direct memory access. That is the DMA controller should go through the DMA controller. Otherwise, we don't have to go through this one. Directly go to the CPU, then store it at the memory. So who is in charge of the operating system, right? Such as the direct memory access command, like read such information, source and destination address of the memory. Okay, read mode, whether this is the right mode, and should know the size of the data should be transferred. Okay. Then finally read the data and store it at the memory. Then when it's done, so you can interrupt, then inform to the CPU, the direct memory access is done. Also, application, not only just the operating system or the CPU, application level, you can access the data definitely, but at the time, such a application level I/O interface is abstracted. Okay, it's an abstraction level. Okay, like this one. So you have kernel. That kernel is a part of the operating system, which is called the kernel I/O. In the operating system level, it has the hardware part is abstracted, so you can use any input and output device. So without go through directly access the disk controller or any controller. Okay? The operating system provide, and even the application, the API some of the ID provide API, then using the API you can access such data. But mostly they are based on the operating system. However, there are, in terms of the application level, there are different types of the IO devices that you need to consider in your programming. So, for example, data transfer. Sometimes it's a block by block. So block IO, such as a disk drive. Okay, hard disk drive is the IO is based on the block, as we have seen. So sometimes a small block, 512 byte, but sometimes it can be bigger. So in your file system, in project B, it will be 256 byte. Okay, so 256 byte. However, other IO devices such as the terminal. What is a terminal? Terminal is a kind of screen. Your output devices, but it doesn't have any input. It's just only does not have the. It's a terminal. It's the end of the computing architecture. Is the output devices directly connect to the server. But nowadays, such a dummy terminal is not used. Any screen is such a CRT screen is character based, not the block based. Example of such a character based data transfer mode in nowadays is a console. Okay, so if you consider console as IO devices, output device is character based. Some of the devices are random processing. Okay, however, like the magnetic tape device is the sequential, also modulator and modulator is the sequential access. Also, regarding to the transfer schedule, such I/O can be synchronous and asynchronous. Synchronous means you need to receive, you need to confirm the data is received, then send it again. It's a serializer. On the other hand, asynchronous is you just keep sending. Sometimes the data that is sent lately, late data will arrive earlier than other, so you need to manage the order of the data in case of the synchronous. So such a I/O direction is sometimes read only, and read and write in your application folder. You need to consider such a. Okay. So each operating system has their own I/O subsystem. The application doesn't have to worry about, the user doesn't have to worry about such a I/O structure. Okay, so highly abstract. In case of the character, so you can read the data using the get command, the system code, and put the data as an input in the system code. So mostly the keyboard, mouse, and serial code. And network devices. Okay. This is based on the socket interface. Socket is one of the communication methods that we have discussed. Inside the computing architecture, it uses the interprocessor communication IPC, but outside, mostly use the socket interface. Okay. Another types of the device is clocks and the timer. So you need to know the clock work time, okay? What is the current time and what is the period time for the timer? So there exists inside the motherboard, there exists such a device, so you can check, you can get the system clock, hour, and system timer. But this is the synchronous and asynchronous I/O method. You can see until the data is confirmed to transfer the data. That should be the confirm. Then can read the data again, but in asynchronous mode. So even though you do not receive it, but you can still send and receive. Can be received later. It can be received earlier. That's not. To perform the multiple I/O, it can be a vector, it can be group, and the sender signal and put together like the read the VE. Instead of the read, it's a read the VE system call, so it can perform the several multiple I/O at the same time for the better performance. So kernel I/O subsystem is a kind of abstraction level that can control the controller and the devices, then provide the API to the application level. So that means operating system manages such a I/O subsystem. For example, if you have such a number of devices, operating system manages the status of each device. Then each one has a queue. Then it can be scheduled in case there are multiple requests. Okay, so this is the I/O subsystem managed by the operating system. There are two data structure managed by the I/O subsystem, kernel I/O subsystem. One is buffering, another one is caching. There are actually two main things. What is the different thing? Buffer and the cache. These are actually the common questions when I had an interview. When I worked for the company, IT department, whenever we are searching the new person, so actually we had an interview at the time. My supervisor and me asked the two very common questions, very simple question. One is what is the difference between fork and EXEC system? Surprisingly, not many actually the interviewee can answer the difference between the fork and EXEC. Another one is the difference buffer and cache. Data structure, right? For what? What's the main difference? Buffer is
doesn't store, but cache stores.
both of them store the data.
Buffer is more towards streaming data that's
Streaming data in case of what? The streaming data is the example. Okay.
it helps prevent like any network.
Network is the example. Okay. The general computing architecture. When do we need buffer? Actually, when you drive the Medic Parkway, you can see a lot of yellow stuff. That is a buffer, right? So the plastic, the structure that include sometimes sand or water. So if you hit the water before that, there's a buffer, right? Buffer can protect the people, driver from the accident. How? Because it can reduce the speed, okay? So buffer. So where can you find such a buffer in your computer? Mostly network or the streaming. So nowadays, because my network bandwidth is bigger enough to watch the live video stream from my hometown. Okay, but a long time ago, so my home network is just 100K, 128 KB, but my hometown, the broadcasting system, they send 1 megabyte. 1 mega BPS, the video stream. I cannot watch it, but you can watch using buffer. The buffer is temporary area temporary structure to keep the data for what? In between to reduce the gap of the two different speed. Okay, this one is a fast, this one is slow. This one is the higher bandwidth, this one is a slow bandwidth. At that time, you can put the buffer, okay, then reduce the gap. So slow media may not realize such a disconnection, okay, using such a buffer. It's the same thing in the I/O. I/O, we have a lot of, some of them are very fast, some of them are slow. So especially the CPU needs very fast input data, but the I/O device such as the disk is slower. So we can put the buffer, then keep the certain amount of data, then the return to the fast bandwidth or the slower bandwidth, something like that. That is the buffer. So main